Hello, Calculus. Wednesday's class, the area between two curves. All right. When we're looking at the area of between two curves, let us think of it like this. Suppose this is f of x, and this is, g of x, and I want from A to B so I want the area between the two curves. So I'm thinking about this area right here. Well, if I took the integral of just plain f of x from A to B, that would give me the area from below this curve and above the x-axis. So it would give me this. And if I looked at the area from A to B of the lower curve, that would give me the area from between the x-axis and that curve. So what could I do with those two numbers, this value and this value, to get the desired value? You can probably see that I'm going to take this upper curve minus the lower curve. And that is basically the theory that I'm going to leave you with. The area between two curves from A to B is the integral of the upper curve minus the lower curve. Alright, so that's the theory that will guide all of your work. So let me give you a specific example. Suppose I want the area between, and before I do that, I do want to have a discussion. Suppose we have one curve like y equals, I don't know, x squared plus 2, something like that. And we have, so if this is y equals x squared plus 2, and say this equals, so as it go through the origin, y equals negative x, if it goes right through the origin here. Suppose I want the area from A to B, between these two curves. So the area between these two curves, we have this whole area that I'm lightly shading. So would this work? Would the upper curve minus the lower curve work? Well, when I do the integral from A to B of the x squared plus 2 curve dx, it's going to give me this area, and it's going to make it a positive number. So a positive number. And when I do the area from A to B of this curve, since it's below the x-axis, it's going to give me this area, which is a negative number. So do you see what's going to happen? When I take the upper curve minus the lower curve, I have the upper curve, a positive number, minus the lower curve, which is a negative number. So I end up with a positive plus a positive. So it will give me the entire area. Alright, so it does work when the curve goes below the x-axis. And sometimes we're going to drop this A and B stuff, and the question will be something like this. Find the area between two curves. Well, that's what we have been doing, but it'll say the area between two curves, between, say, f of x is 2 minus x squared, which is the frowner raised up to, and g of x, equals x. So this time I didn't say between A and B. So I really am asking, find the area that is enclosed between these two curves. So let me give you a sketch of that. All right, so this is something like this, that one, and g of x, y equals x is like that. So when we're talking about the area between these two curves, there's no a and b involved. It's just between here and here. So in order to do that, we need to know the x value from this intersection point and the x value from this intersection point. And we'll integrate from the lower x limit to the upper x limit. So let's see what that will look like in this case. So how do we get these intersection points? Well, it's where these two curves are equal. So I'm going to set them equal and solve for x. Hopefully this is factorable. It is x plus 2, x minus 1. So that equals 0, 0. So that means x equals minus 2 and x equals 1. There's two x values where these two functions are equal. So this must be the x equals minus 2, 1, and this one must be the 1, 1. All right, so now we're going to set this up. Is the upper curve is 2 minus x squared, and the lower curve, so it's be the upper curve minus the lower curve, y equals x, and all that from these x values, negative 2 to 1. So you can see how that works. And the only other complication that I want to mention, and then of course I leave it up to you to integrate and put in the upper limit and the lower limit and so forth. Alright, and now that we have been so good at that, I do allow you to use your calculator for some of those too. What if, last complication, we have a curve, I'll dash this one so you can see it clearly. Suppose we have some kind of cubic curve that goes from down to up. I don't know, y equals 3x cubed minus x squared minus 10x. I don't know, something like that. And then we have another curve that, this keeps going, so another curve that is a parabola. Let's see, I kind of want to angle that slightly differently. Alright, a parabola, something like this. Alright, do you see the complication that this has? So I want the area between the two curves. So I'm looking for this plus this. The complication is that these kind of flip-flop. And this dashed one, which is, and what did I'll call this some quadratic, minus x squared plus 2x. So this dashed one goes up, down, like that. Notice on this section, it's the upper curve. And on this section, it's the lower curve. So how are we going to do upper minus lower when they flip-flop? Well, you're going to have to do it in pieces. So first of all, you're going to have to find that point. So this one happens to be minus 2, minus 8. We don't really need the minus 8 part. And this is 0, 0. And this point is 2, 0. You have to come up with that, or it has to be given. So on the first integral, the upper curve is this one. So we're going to have the integral from the x value only, minus 2 to 0. And we're going to have the upper curve, which is 3x cubed minus x squared minus 10x minus the lower curve, negative x squared plus 2x. And before you integrate, you can combine all like terms. Then you're going to add to that the integral, the area between these two curves. This time the upper curve is, and it goes from 0 to 2, running out of room here, but I think you can get the gist. 0 to 2, the upper curve this time is the minus x squared plus 2x minus the, let me get rid of that, that's the time I have for this video, which is, I think it's going to fit, minus the lower curve, and this time it's this dashed one, 3x cubed minus x squared minus 10x. Alright, and all that, the integral dx. Alright, so that will give you that. So I didn't really work any to completion, but I was showing you the theory of the area between two curves. Alright, I hope you enjoyed that, and we will work with those kind of problems soon. So, carry on, class, carry on.